Welcome to a lesson with Dr. Powell. Let's talk about how we can um, come up with what the formula for a polynomial is if we have some information about its zeros. For instance, let's suppose we know we want a degree 3 polynomial. Now, what does degree mean? Degree means just the exponent of the degree of the leading term. So if the leading term, is something like this plus something with x squared and so forth, degree 3 means this. Okay, so we want it to be a degree 3 polynomial, and also suppose that we would like, let's see, 1 plus I to be one of the zeros. And also suppose that x equals 2 is also 0. So and maybe we have another condition. Maybe we know something like, for this polynomial, that like f of 0 is equal to 1. Okay, then the question is, can we write down what this polynomial would be? Okay, well, let's try it out. First of all, we know it has to be degree 3. I only gave you 2 zeros, so how could you come up with that? For one, if you know this is a 0, then you know that x minus 2 is a factor, just the same way as when you plug in 2 in the synthetic division, and you get 0, that x minus 2 would be a divisor and also a factor. So no, x minus 2 is a factor, but we also know something else. We also know that x minus 1 plus I, wow, that's also a factor. But we need 3 factors if we're going to get to a degree 3 polynomial. So how is that? Well, think about what I is. I actually comes from taking a square root of something, in particular the square root of -1. Now, complex numbers and square roots even, it doesn't matter, just any square root. Even if I had given you 1 plus square root of 2, it would have been the same idea. Square roots always come with a plus or minus in the solving. So if I give you 1 plus I, you automatically know, since at least in a quadratic, if we had factored this out and have a quadratic portion of it. So if I give you 1 plus I, you also know automatically the 1 minus I will also be in here. So not only do we have x minus 2 times this right here, but we also have x minus 1 minus I. Okay, so we just say plus or minus on the square root part. In this particular case, it's I is the square root part. Okay, so really this is the polynomial that we're after. Now it's, well, great. It's in factored form, but maybe we don't like the presence of I being here. Now, if we multiply this out, we'd actually notice that this part becomes just a regular polynomial with no i's at all. One way you could think of this in multiple ways. But perhaps the simplest way is just to think about completing the square backwards. We know we're going to, in the end, arrive completing the square with something that looks like this. X is equal to 1 plus or minus I. And that's going to be solutions here. Well, when we multiply this out, we're going to get a nice quadratic. And the quadratic we get can actually be obtained by completing the square backwards. Meaning, let's isolate the square root portion, which is just the I. So let's subtract the 1 over. And then square both sides. Now, when we square both sides, the plus or minus goes away. And this side becomes x minus 1 quantity squared. And this side, if you square I, you get -1. And the plus minus goes away. Next, we can add the 1 over. and there's our original equation. Well, this is the quadratic factor we were interested in that we wanted to set equal to 0. In fact, we could multiply this out and see we get x squared minus 2x plus 1 plus 1. If we foiled this out as x minus 1, we would see that. You always get, the middle term is always double this guy times that guy, and you can check anyhow that. So we can get that. So we end up getting x squared minus 2x plus 2. So in the end, we end up getting our polynomial that we're interested in. Let's see, we end up getting x minus 2 multiplied by x squared minus 2x plus 2. And that's our polynomial, except maybe we need to double check something. When we plugged in 0, I wanted to get 1. So maybe we might have to multiply a constant out here to make sure that's right. So I'm just going to put an a down here because I don't know. So if I plug in 0, let's just see what happens. If I plug in 0 everywhere, in this particular case, that becomes just -2. Plug in 0 here, I end up just getting 2. Well, that means I end up getting -4 times a. So that's what happens when I plug in f of 0, or plug in 0 to f. But I wanted, this is the condition, I wanted f of 0 to be equal to 1, so that's equal to 1. So guess what a is? -1/4. So really my polynomial ends up being just simply this, -1/4 multiplied by all that. And I'm done. We've just come up with that. Now, I'm okay with you ending here. You could keep on multiplying it out, but this is fine because I see my polynomial. It's in factored form, but at least the factors don't have any imaginary complex parts to it, and that's just fine. That would be okay. I guess the other way you could have done this, and maybe I'll just illustrate that briefly for those that might be interested. I'm just going to think of this as being, okay, let's see, that's the way I'm going to rewrite this, you see, as I'm going to distribute that negative and rewrite it and regroup it a little bit so it looks a little better. So x minus 1 distribute to the minus I. Then here distribute x minus 1 plus I. Now there's a reason why I did that, because I can make a block here around the x minus 1s. Then this looks like a difference of 2 squares. So because this is like a minus b times a plus b, the inside and the outside cancel here, negative ba and ab. So it'll be like a squared minus b squared when you multiply it out. In fact, that's exactly what we get. We simply get x minus 1 quantity squared, and then we have minus just I times I, which is I times I is -1, so we just get minus a -1 as that square. So we end up just getting x minus 1 quantity squared plus 1, which is exactly what we had before in order to get that. So either way we do it, we were able to get this. Now, just remember that was a negative right there. Okay. Thanks for watching.